I'm going to be talking about automated depth matching, and we're using artificial intelligence technique. I am Fred Jensen, and Shiran Ranganathan is the person who did the development of the application. So why would you want to depth match data? There's a whole bunch of depth matching scenarios, and we'll cover the majority of them here. The log curve depths do not match from one logging descent to another. So you go in with a dual sonic gamma ray and you log it, and then the engineer goes in with the density neutron gamma ray and he logs it. Those logs are very often off depth. They're not off by a lot, but even a couple of feet will make a big difference when you're doing your water saturation and your porosity calculations. And those errors invariably will decrease the amount of reserves you're calculating and affect your estimation of your reservoir potential. So it's important. The LW-MWD log curves, being that they're measured in drilling time rather than depth, almost never match the open hole curve data, and those shifts are often very difficult to make. Case hole logging curves can be off depth, and that can be disastrous because you perforate and frack your wells based on those case hole log curves. And then tool pulls can cause depth discrepancies, and those we can correct somewhat, but they're difficult to correct perfectly as the pull distorts the curve data. So why do you want to use automated depth matching? There's a variety of reasons, and the first one and the most important is it saves enormous amounts of time. Our internal consultants have stated that they could process 20 wells in a couple of hours, and we've heard this from different locations, using automatic depth matching techniques versus about a week doing it manually. It's reproducible. It does not depend on the person doing the work. You get very higher quality depth shifts. And I know, and this is the one I've had the most feedback on, negative, and they say, oh, I could do better by hand. And I think after you see the quality of the depth shifting, I feel safe in sometimes disputing that. And you can apply it to multiple wells, as many wells as you want at the same time. Now we're going to show 3 different methods of automated depth matching. Today we're going to show the module, which is an editing module, which is more versatile, has various options for depth matching, and it's the one that can process multiple wells, as many wells as you would like at the same time. We're going to show a log plot, which is our log plotting software to view the log data, an interactive automated depth matching functionality, and then we're going to take a quick look at our prototype cloud automatic depth matching microservice that we actually have working now, and we are getting closer to having it ready to be released. So let's go ahead and start the demo, and let's look at the data. Okay, so here we're running PowerLog. We're running our latest release. We're going to do an example where we take a look at 5 wells here. And this is our automated depth matching module. And this is one of the first wells we're looking at. This is the Intex well. And you can see we have a gamma ray. We're doing the normalized gamma ray. And then we have an LWD-MWD gamma ray that's way off depth. It's, multiple 20 feet plus off depth. And in addition, we have a sonic that is off depth as well. So we want to see if we can go in and automatically shift this to match. And if you look, we can see we have multiple wells of different intervals, different logging distances, and they are all have considerable depth shifts that are needed to fix them. This one looks closer, but that's kind of deceptive because we're looking at a much greater logging interval. And you can see that this one is quite a bit off depth as well. Then there's another well and another well, and we will be doing all of these wells at the same time. So let's go back to our starting well. And then here's the depth shifting module. To set up, you define the curve you want to be the reference curve. This is the curve you're going to shift the other curves to. And the curve you're going to fix is the curve that's off depth, and it's the gamma ray GRR curve. So we're going to be shifting a GRR to a GR NRM. In the case of you're doing resistivity curves, you do want to use the logging option. These are similar curves, they're very similar. And we're going to do an optimized computation. And the optimized is more for speed than it is for algorithmically optimized. It's a little faster version. And we have the option of putting in a shift limit, and we're not going to do that in this case. And when you use the module, I recommend you don't do it initially. And if you see that you're having overshifts, then you can use the shift limit to protect from overshifting. We're going to do the working interval, and we're going to use the default sampling grid. For the outputs, we're going to call the output curve GRDS, and we're also going to be shifting a sonic at the same time, and we're going to do a generate report. We have a splice result, and I'll get more into that later. So let's go ahead and run this module, and it's done. It's very fast. And first off, we're going to get a shift table for all 5 of the wells. And this is the depth shift table that you can save and apply to other curves that require the same shift. You have that option. You'll note that the shifts are different from well to well. Each well has a separate number of shifts. And you can see the correlation before was around 26%, and afterwards it's about 93%. And it's the same kind of numbers here. So those are outstanding results. So let's go ahead and take a look at how all the wells did. This well looks very good. This well looks good. We can zoom in and see intervals where we may have, look at them in more detail. And you can see that, and this is what I said, I find it hard to believe that a person could actually do it better by hand, but I've known people who would disagree with me. And here you can see this one looks great. And this one looks great as well. So we've got a good answer, and we're going to do it. And this well, let's zoom in on a couple of areas and see some points here. First off, here's an area where we're actually logging across the gap. We're doing the depth matching across the gap. And the software is intelligent enough that it can actually detect the gaps, and it can handle the shifting across the gaps. Now, one thing we've noticed in running this on a lot of wells, and we've been doing it in test mode for quite a while, is that occasionally on the bottom, it will have a little difficulty coming off bottom. And in this particular well, you can see that indeed we are having difficulties off the bottom of the well. So we want to come down and address that. So let's bring our depth module back up again. Automated depth matching. You see now it's highlighted to that well. We're going to do a splice result. We're going to go from, say 5,300, somewhere above where it's tied in really well. And then we're going to go down to right near the bottom of the well. We could probably do the bottom of the well and get good results too, but let's try that. And then we're going to rerun it. And you can see it's now shifted this area beautifully and spliced it automatically with the area above it. And now you've completed the analysis on this particular well. So let's scroll up and make sure all the other wells are done. It looks beautiful. We're very happy. And so we finished it. And that's the module for automated depth matching. And it is currently available by subscription today with this version of PowerLog. So let's look at another way you can do the depth shifting. In order to do that, we need to get rid of the curves that are already shifted. And we just use our undo option, and it undoes the last processing. And now we can start again from scratch. This one is interactive with PowerLog. So we go to the depth matching module in PowerLog, and it asks us, what curve do we want to shift? Well, we want to shift the gamma ray. And what curve do we want to use as a reference? We want to use the gamma ray NRM. It names it for us automatically. You have some options on how you want to do the normal with resampling, normal or discrete, default sampling grid. We're going to use the auto depth match option. And now you'll see that it's very similar to the module. And once again, they're similar curves. We're going to use optimize. We're going to do the working interval. And we're going to apply. The shift table is stored over here. And let's go ahead and do something in here. We're going to add a track. We're doing this to make it easier to see what's going on. And now you can see where we've done the depth shifting and how the data has been shifted. Let's zoom in on an area. And the reason we say this one is interactive is because you can go in, and if you have a disagreement with the way the algorithm did the shifting, you are welcome to go in and adjust it slightly and make the change. If you want to shift other curves, you can go to the shift other curves. It'll input the table automatically. Here you have the curves, and you're going to shift them. And once again, we're shifting the orange curve to the green. We run it, and it makes the shifts. We close it. We say we're happy with our depth shifting. We commit them to the database. Exit the module. Save the shift table. We've done this before, so we're overriding it. And boom, we're done. We can eliminate this other track and look at the entire interval. And you can see that now we have done a beautiful job of depth shifting the gamma ray NRM, the GRR to the gamma ray NRM, and also the DTC to the DT curve. And we're completed at that point. So this is the interactive depth shifting module. Now at this point, we're going to go in and we're going to actually change wells. And this well is slightly different. We're going to do something a little different here. This is a well where one descent does not match exactly the curves from another descent. And the two curves that we're going to be shifting here is a neutron versus a gamma ray. And let's zoom in on an area, and you can take a quick look and see why we think we need to be shifting these curves. You can look at any area. You can see. And as we scroll down, you can see that there's a shift. Now notice that the shift is not great. This is only 1 meter in depth. This is a North Sea well, so the depths are in meters. But if you look down, if you had done your calculations of water saturation and everything, yeah, your porosity curves are off depth with your resistivity curves probably, and you're going to get some really bogus answers. So we need to get these shifted to match. So let's go ahead and bring up our cloud base. Now this is an extension. PowerLog has this ability to generate Python extensions that function as modules within PowerLog. And this is our cloud prototype. And you'll see it looks much like the module that we saw earlier today. And you start off with the same type of reference curve, the curve to be shifted. Gamma rays and neutrons are pretty similar curves, so I'm going to say they're similar curves. I'm not going to optimize the processing. I'm going to say false, and this does a more rigorous computation, uses a slightly different artificial intelligence routines to get that. We're not going to put it in an overshift guard on the first pass, but if we run it and we notice we need to, we can put it in on the second pass. Now this is a prototype module. It's not finished. We haven't added the ability to shift other curves and other features that will be added before it's released, but we're ready to go with it. So we're just going to generate an output curve, and we're going to be watching the console. Now, I'm telling you it's running in the cloud, and the console, although I didn't show it in the module, the console actually watches what's happening and feeds you back information. So we're going to run it. It's going to go to the cloud. It's sending the data right now, and then it's going to use password authentication. We're using Active Directory for password verification. And then we have a license verification as well, that the user ID has access to a license. And that's a way we can do where people can come use a CGG cloud, do their depth shifting, and then get the data back. You'll see that we had a 62% correlation before and an 82% correlation afterwards. So we got some pretty good results. You can see that it looks a lot better than it did before. You know, there's no question that we have really improved it. Now, in the future, we'll probably be making this, and I'll say probably, but almost definitely, some kind of Docker container where you can set it up in your own environment, say if you're using the OSDU, where it'll communicate with a data transfer to a Docker container, do the processing, and then transfer it back. So if you're using software like a competitor petrophysical product, you can access this kind of processors or microservices in the cloud, regardless of what software you're using to do your petrophysical computations. And that's going to be available probably in an upcoming release fairly soon, both, so you have the cloud available. And that pretty well concludes my presentation for today. I think we've shown how you can save really enormous amounts of time in depth shifting logs. You generate very high quality results very quickly. And in here you can see that although they're similar curves, they're not identical. And I think you'd have a hard time personally matching the kind of quality you're getting here doing it manually. So thank you for your time and attention.